In this next section, we're going to talk about a couple different kinds of special right triangles. We have two basic kinds of right triangles, and those are a 45-45-90 degree triangle or a 30-60-90 degree triangle. So in our first one, 45-45-90, this is talking about the three angles of our triangles. So of course we have that 90-degree angle in a right triangle. But our 45-45-90 is saying that these other two angles in our triangle are both 45 degrees. And when we have a 45-45-90 degree triangle, the relationship of the sides here are always going to be the same. So our sides of this triangle, our A and B, are always going to be 1, and our C is always going to be the square root of 2. In our 30-60-90 degree triangle, this means we have our 90-degree triangle again with a 90-degree angle. One angle is going to be 30 degrees and another angle is going to be 60 degrees. And the sides of this triangle, we are always going to have the side across from angle 30 is 1. The side across from angle 90 is 2. And the side across from angle 60 is the square root of 3. So when we have a 45-45-90 degree triangle, there are a few facts. The first one is that all of the legs are always congruent. So that means that our legs here are congruent. We have 1 and 1. And then we also know that all 45-45-90 degree triangles are similar. So no matter how long the sides are, how big the triangle is, if they have 45-45-90 inside that triangle, they're always going to be similar. Same goes with 30-60-90 triangles. If our triangles all have 30, 60, and 90 degrees in their angles, then they are all similar, no matter how big they are. So let's look at some examples. Okay, our first question is asking us to find the missing measures in each triangle. So here we're missing two sides. So even though we have a right triangle, we can't use our Pythagorean theorem because we only have one side. That means we have two variables, two unknowns. One way we could find the missing angles is to compare it to a similar triangle that we do have all the information for. So if we look above, we have a 45-45-90 triangle that we had information on all the sides. So we know that our triangle, if we draw it down here in a similar manner to the one we're comparing it to, we know that if these angles are 45, this is 90. We know across from 90 is square root of 2. And then our two legs are 1. So now that we have a similar triangle to compare it to, we can figure out what those missing sides are. So if we set up a proportion, if we start with this side compared to this side and set it equal to this side compared to this side, we can figure out what A is. And you can cross multiply. A times 1 is A, 3 times 1 is 3, so our A equals 3. And then we can do the same thing for our other missing piece. We have our proportion 1 over 3 is equal to square root of 2 over D. Cross multiply, 3 square root 2 is equal to D. and those are our missing measures. Okay, so let's look down at the next one. Okay, so if we draw another similar triangle, 90, 45, and 45, we can compare it to this is the same triangle I drew right up here. I'm just copying it down. So I have the angle straight across 90 is square root of 2, and my two legs are 1. And now I'm going to figure out what x and y are using my ratio. So if I have square root of 2 over 5, I know that's going to be equal to 1 over y. Cross multiply, we get y times the square root of 2 equals 5. Now I need to divide by the square root of 2, and I get y equals 5 over the square root of 2. But on our last unit, we just talked about how we cannot have square roots in our denominator, so we need to still change this answer. We multiply both the top and the bottom by square root of 2. We get 5 square root of 2 on top, and we get square root of 4 on the bottom. So we're left with 5 square root 2 over 2 is our answer for y. And when we do the same thing for x, we're going to set up a similar proportion. So you can do the same thing to solve for x. The other thing you can do for 45, 45, 90 triangle is if we know that our angles are the same right here, they're both 45, that tells us it's an isosceles triangle. Both angles are the same, so both our sides are the same. So we don't even have to solve for x. If we found y, we know that x is going to be the same thing as y. So you would get the same answer either way you do it. But if you remember that that's an isosceles triangle, and if two angles are the same, then their two opposite sides are the same, then you don't even have to solve for x. You know right away it's going to be the same as y. Okay, now we're going to try a couple examples with a 30, 60, 90 triangle. So I'm going to draw my triangle from above. Whenever I have a 30, 60, 90 triangle, I know the side across from my right angle is 2, side across from my 30 angle is 1, and the side across from my 60 angle is square root 3. So now I have a similar triangle to compare this one to. I can set up my proportion now. If I have 2 over 50 is equal to 1 over x, I can solve for x. So I have 2x, and that is equal to 50. Divide by 2, x equals 25. To find y, I'm going to set up a similar proportion. So I'm going to use my same starting ratio. I know 2 over 50. And now I'm going to use my y value instead. So I have square root of 3 over y. You can solve this for y by cross multiplying. I get 2y equals 50 times the square root of 3. Divide by 2, and y equals 50 divided by 2 is 25 square root 3. Okay. Number 4, I'm again going to draw a similar triangle to help me compare. So if I have my 30, 60, 90 triangle, 30, and 60. Across from my 90 is 2, across from my 30 is 1, and across from my 60 is square root of 3. Make sure you're checking back to our original drawing here so you always get those side lengths correct. You are able to use your notes on your homework and your tests, so there's no reason you should get this triangle wrong. So now if we set up our proportion, we have square root of 3 over 6, and that is going to be equal to 1 over r. Cross multiply, we have r times the square root of 3 equals 6. Divide by the square root of 3. R equals 6 divided by square root of 3. There should be a warning, I got a square root on the bottom, so I need to change that. Square root of 3. I get 6 times the square root of 3 on top, and then the square root of 9 on the bottom. 6 over square root 3 divided by square root of 9 is 3, because 3 times 3 gives me 9. And then I can divide 6 by 3. So my final answer here is going to be 2 square root of 3 equals r. Okay, I've got to do it one more time to set up my ratio for s. So I have my original ratio, square root of 3 over 6, equals 2 divided by s. Same thing, cross multiply. Square root of 3 times s equals 12. Divide by square root 3. Here we have s equals 12 square root 3. Get rid of that square root on the bottom. Square root of 3 over square root of 3. 12 times the square root of 3 over square root 9. I know square root of 9, just like before, is 3. And 12 divided by 3 gives me 4. So I'm left with 4 square root 3 equals s. So those are my final two answers for number 4.